Jai Hind children. Today we are going to study some proof based on the identities of trigonometric functions. Come to the first question. Prove the following identities where the angles are acute. The angles mentioned in the question are acute angles. You need to prove the identity. In the proof, always you will be given with an LHS and an RHS. Either take the LHS, make a proof to get the RHS, or take the RHS to prove to get the LHS. This is the way. Okay, we can start. Here I am going to take the LHS. LHS is given to us root of 1 plus sin A by 1 minus sin A. Now, the expression is in the root of the form A by B. For to make this expression comes out of the root, you know that it needs to have a square. So, my first aim is to make this expression comes out of the square root. For that, I am going to make a simplification. Equals, the simplification is root of 1 plus sin A by 1 minus sin A herewith. For to comes out of the root, I need to multiply the numerator as well as the denominator by another term, that is, if 1 minus sin A in the denominator, I am going to multiply with 1 plus sin A in the numerator as well as 1 plus sin A in the denominator. So that 1 plus sin A, 1 plus sin A when get cancelled, you get the same expression. So here the procedure is multiplying numerator and denominator by 1 plus sin A. Remember this term which you need to multiply. This 1 plus sin A is actually, we can say that's conjugate, that is changing the sign in between. 1 minus sin A becomes 1 plus sin A. That 1 plus sin A I am multiplying on the numerator and denominator. Our aim is to make this expression comes out of the root. Now your expression becomes equal to root of 1 plus sin A into 1 plus sin A becomes 1 plus sin A the whole square divided by, the denominator becomes A minus B into A plus B form. The denominator is of the form A minus B into A plus B form. Am I right? What is A minus B into A plus B? A square. A square means 1 square minus B square is sin A the whole square. This can be written as equals root of 1 plus sin A the whole square divided by 1 square is 1 minus sin A the whole square, in short can be written as sin square A. Now I am going to make the simplification here equals root of 1 plus sin A the whole square. When comes out of the root you get 1 plus sin A, but I am going to write like this itself, 1 plus sin A the whole square divided by, what is 1 minus sin square A? 1 minus sin square A, you know that sin square A plus cos square A equals 1. Therefore 1 minus sin square A. Sin square A when comes to the right side becomes 1 minus sin square A. What is 1 minus sin square A? 1 minus sin square A is cos square A. I am going to replace this 1 minus sin square A with cos square A, which is cos square A. Actually, you know that cos square A is equivalent to cos A the whole square. Cos square A is the same as cos A the whole square. So, this is equal to root of 1 plus sin A the whole square. When comes out, you get 1 plus sin A by cos square is actually cos A the whole square. The cos A the whole square when comes out of the root, you get cos A. So, our aim is to make this expression comes out of the root. For that, you need to take a square within the square root. That is what we did by multiplying with 1 plus sin A on the numerator and denominator. At last you reach the step. But look at the RHS. Your RHS need to be CK plus tan A. The next step is I am going to make a division as separately dividing 1 by cos A plus sin A by cos A. Am I right? Why? Because in this step, if you take the LCM as cos A, the numerator becomes 1 plus sin A. That is actually the step above. So, this fraction you can separately divide as 1 by cos A plus sin A by cos A equals. What is 1 by cos A? 1 by cos A means the reciprocal of cos A. Am I right? The reciprocal of cos A, that is sec A, plus sin A by cos A is tan A, which is your RHS. Thus, taking the LHS, make the simplification by multiplying with the 1 plus sin A on the numerator and denominator. The numerator becomes 1 plus sin A the whole square, by denominator is of the form A minus B into A plus B, A square minus B square. 1 minus sin square A, apply with cos square A. So at last you will get 1 by cos A. 1 by cos A is actually the reciprocal of cos A. Reciprocal of cos A is sec A. And also one more formula you need to apply here, sin A by cos A. Sin A by cos A is tan A. Thus, taking the LHS, you can arrive at the RHS. Hence proved. Hence proved. Come with another question. Prove that 1 plus tan square A by 1 plus cot square A equals 1 minus tan A by 1 minus cot A the whole square equals tan square A. 2 equal to sin are there in an expression. How we can prove this? Remember, suppose you are given with an expression A equal to B equal to C. So how to prove this? You need to prove A equal to C, you need to prove, and the same way B equal to C also you need to prove. Both the expressions you need to prove separately. In the same way, first you need to prove that, first proof is to prove the expression 1 plus tan square A by 1 plus cot square A. The first expression that in it should be equal to tan square A. And second you need to prove also the second expression 1 minus tan A by 1 minus cot A the whole square. That also should be equal to tan square A. So, for to prove expressions of the form A equal to B equal to C, you need to prove A equal to C as well as B equal to C. Both of them you need to prove separately. Come with the first part. Here, LHS equals 1 plus tan square A by 1 plus cot square A. Now, we have what the formula known for you here, sec square A minus tan square A equal to 1. And the same way, cosec square A minus cot square A equal to 1. These are the two square relations for to get the identities 1 plus cot square and 1 plus tan square A. I am going to apply these two results. Okay, what happened to the LHS now, which implies 1 plus tan square A can be replaced with 1 plus tan square A can be replaced with sec square A by 1 plus cot square A can be replaced with cosec square A by the above identity. You need to prove the RHS as tan square A. So again I need to make a conversion which is equal to sec square can be written as 1 by cos square A because sec A is the reciprocal of sec A. We have sec A equals 1 by cos A. Sec A and cos A are reciprocal to each other. And the same way, cosec A is the reciprocal of sin A. These are the two formulae I am going to use in this step. So, Applying in this step, we can see that sec square a can be replaced with 1 by cos square a, the whole divided by cosec square a can be replaced. Cosec a is 1 by sin a. So cosec square a is 1 by sin square a. You know how to divide two fractions. Write the first fraction as if it is. Take the reciprocal of the second and multiply into sin square a by 1 is the reciprocal of the second. So net value will be sin square a, 1 into sin square a is sin square a by cos square a into 1 is cos square a. What is sin square a by cos square a? Which is equal to tan square a. Why? Because sin a by cos a is tan a. So sin square a by cos square a equals tan square a, which is your RHS. This is the first part. Taking A and to prove which is equal to C. Now come with the second part. Second part is you need to prove 1 minus tan A by 1 minus cot A the whole square equals tan square A. Here I am going to prove the second part this way. In the second part I am going to apply the identity. We have I am going to apply the identity cot A as the reciprocal of tan A. Am I right? Cot A and tan A are reciprocal to each other. I am going to apply that in the given expression. So your LHS become equal to 1 minus tan A divided by 1 minus cot A. Cot A can be replaced as 1 by tan A. Now a whole square is there with. Here numerator is 1 minus tan A, correct. The whole divided by. In the denominator I am going to take the LCM as tan A. When taking LCM tan A, here comes with the tan A minus 1. Tan A minus 1. So this is the denominator. The whole square there with. Actually this is your numerator and the tan A minus 1 divided by tan A is the denominator. Now how to make a simplification within the square, which implies the numerator, the first fraction I am going to write as if it is. Denominator, the second fraction, that I am going to multiply with tan A by tan A minus 1, division of two fractions. This is also within the whole square. Now 1 minus tan A into tan A divided by. Looking at this, you can see that tan A minus 1, when taking a minus outside, it becomes 1 minus tan A. Am I right? When taking a minus outside, it gets reversed. That is, negative becomes positive and positive becomes negative. Check it. Minus 1, correct. Minus of minus plus tan A. So plus tan A minus 1 can be reversed by taking a minus sign outside. This much expression is in the square. Don't forget to put the square there. Now, looking at this, you can see that 1 minus tan A can be cancelled with 1 minus tan A. What remains there at last? Which equals tan A divided by minus 1. That is minus tan A is the only thing within the square. Minus tan A, the whole square is the only thing. Here, within this bracket, you get tan A by minus 1. Tan A by minus 1 is minus tan A, the whole square. The whole minus tan A, the whole square is same as minus 1 square, you get plus. Tan A, the whole square is called as tan square A, which is the RHS. Come with another question. Prove that cosec A minus sin A into sec A minus cos A equals 1 by tan A plus cot A. Here also I am going to take the LHS to get the RHS. LHS equals cosec A minus sin A into sec A minus cos A equals. I am going to apply the formula here. Cosec can be written as cosec equals 1 by sin A. And you know that sec is the reciprocal of cos. So 1 by cos A. These are the identities I am going to supply in the first step. So in the first step, I am going to apply this one. So cosec can be replaced with 1 by sin A minus a sin A therewith into the second bracket sec can be supplied with the value 1 by cos A because sec is the reciprocal of cos minus cos A. This is the second bracket. Usually what will be the next step, which implies I am going to take the LCM sin A in the first bracket. Here comes with the 1 minus sin A into sin A, sin square A. After taking the LCM, this will be the first bracket. In the second bracket, I am going to take the LCM cos A. So here comes with 1 minus cos A into cos A is cos square A equals. What is 1 minus sin square A? Again apply the identity. Sin square A plus cos square A equals 1. So that what is 1 minus sin square A? 1 minus sin square A can be replaced as cos square A by a sin A therewith. This is the first bracket into. Second bracket is 1 minus cos square A. 1 minus cos square A can be replaced with sin square A. The whole divided by cos A. So in the second step, I applied this result, sin square A plus cos square A equal to 1. Now I am going to simplify this equals. Listen to the simplification. Here a cos square A by cos A. 1 cos A can be cancelled with 1 cos A. As all our multiplication you can cancel. Sin A cancel with 1 sin A here. So what remains there? Equals. The remaining is a cos A into sin A. Actually this is not the RHS. Your RHS is 1 by tan A cot A, but I am going to keep it here. So this is a special method for doing some problems in which while taking the LHS you can't reach the RHS. So keeping at this step, I am going to proceed further. I am going to take the RHS now. My RHS equal to 1 by tan A plus cot A. But I need to get the answer in terms of cos A sin A. How you get cos A and sin A from tan A and cot A? Again we can apply the identity. You know that tan A equals sin A by cos A and cot A can be replaced with cos A by sin A. So for to get the RHS or for to get the answer in terms of cos A and sin A, I need to apply the formula for tan and cot in terms of sin and cos. Okay, we can replace that equals 1 by tan A can be replaced as sin A by cos A plus cot A can be replaced with cos A by sin A. Again equals 1 by, in the denominator I am going to take the LCM cos A sin A. Denominator the LCM is cos A sin A. So here comes with the sin A into sin A, sin square A plus cos A into cos A is cos square A. So this is actually the denominator. This much the full denominator I simplified here. In this step you apply the formula for tan A and cot A as tan A equal to sin A by cos A and cot A equal to cos A by sin A. Again I am going to make the simplification equals. You know how to divide two fractions. Write the first fraction 1 as if it is. Take the reciprocal of the second and multiply. What is the reciprocal? Cos A sin A divided by sin square A plus cos square A. Sin square A plus cos square A. Sin square A plus cos square A equal to 1. So that I am going to replace the value with 1. So cos A sin A divided by 1, which is cos A sin A. So after simplification, you reach the step cos A sin A in the RHS 2. Simplifying LHS, you reach the step cosine sin A. Simplifying the RHS, you reach the step cosine sin A. From this, you can say that therefore LHS equal to RHS, hence verified. Another question. Prove that 1 plus ck by ck equals sin square a by 1 minus cos a. Simple question. I am going to take the LHS. LHS equals 1 plus sec a by sec a. Looking at the RHS, I know well that sec a need to get converted to cos a. What is the relation connecting sec a and cos a? Sec a equals 1 by cos a. Sec a and cos a are reciprocal to each other. This relation I am going to apply in the first step, which is equal to 1 plus sec a can be replaced with 1 by cos a by, here also sec a that I am going to replace with 1 by cos a. This is the numerator and denominator separately. In this step, I applied the identity ck equal to, or relation ck equal to 1 by cos a, the reciprocal relation I applied. Next, I am going to make a simplification which implies, on the numerator, I am going to take the LCM cos a upon cos a plus 1. Am I right? Cos a plus 1. This is the numerator, the whole divided by. On the denominator, there is a 1 by cos a. You are known that in a fraction a by b dividing by c by b, if both the denominators are same, you can cancel them and can write as a by c. In the same way, here both the fractions have the same denominator, so you can cancel, no need to make a reciprocal multiplication. Directly you can do that. So the remaining there is cos a plus 1 on the numerator divided by 1, which is cos a plus 1. Thus, after simplification, you reach the step cos a plus 1. Now, this is the LHS simplification. I am going to simplify the RHS. Your RHS equals sin square a by 1 minus cos a. What is the relation connecting sin square a and cos square a? Listen here. Now what I am going to do, that RHS I am going to make a simplification to get cos a plus 1. To get cos a plus 1, the denominator actually contains cos a. I need to convert the numerator sin square a to cos square a. What is the relation connecting sin square a and cos square a? Sin square a plus cos square a equal to 1. After each step, you need to look at the LHS, RHS and check whether they coincided or not. Here cos a plus 1, the RHS consists of cos a plus 1, cos alone. This is the simplification of the LHS. Now, when taking the RHS, you can see that RHS equals sin square a by 1 minus cos a. This sin square a also need to convert to cos a. I am going to apply the relation which is equal to, what is sin square a? Sin square a can be replaced with 1 minus cos square a. 1 minus cos square a. The whole divided by 1 minus cos a. In this step, I applied the identity sin square a plus cos square a equal to 1. Again, making simplification equals 1 minus cos square a can be written as cos a the whole square. This is called as cos square a. And 1, if want, you can think as 1 square divided by 1 minus cos a therewith. If you want, you can directly write this step without writing this step itself. So 1 can be written as 1 square and cos square a can be rewritten as cos a the whole square. Now apply the identity a square minus b square. A plus b in one bracket into a minus b in the other bracket. This is the numerator now. The whole divided by the denominator, there is a 1 minus cos a. Now you can see that this 1 minus cos a cancel with this 1 minus cos a. What left there? Which is equal to 1 plus cos A. So you can see that RHS is also 1 plus cos A, LHS is also cos A plus 1, which is the same as 1 plus cos A. Therefore, LHS equal to RHS, hence verified. Wisely, you need to take the decision which formula I need to apply. Here on the right side, on the LHS you got cos A plus 1, hence RHS you need to simplify to get a cos A plus 1. An important question. Sin A plus cosec A the whole square. You need to prove that sin A plus cosec A the whole square plus cos A plus sec A the whole square equals 7 plus tan square A plus cot square A. I am going to take the LHS. LHS equals sin A plus cosec A the whole square plus cos A plus sec A the whole square. This is the LHS. Here I am going to apply the identity A plus B the whole square for to expand. A plus B the whole square, when using, you know that A square means sin A the whole square, which is called as sin square A, plus 2 into A into B, that is 2 into sin A into cosec A, plus B square means cosec A the whole square. Cosec A the whole square is called as cosec square A. This is actually the first bracket. Plus, again, this also expand using A plus B the whole square. A square means cos A the whole square, which is same as cos square A, plus 2AB, 2 into cos A into sec A, 2 into cos A into sec A, plus B square means sec A the whole square, that is called as sec square A. Now I am going to remove the bracket and to arrange equals. Sin square A plus 2 sin A into cosec is the reciprocal of sin, so you can write as 1 by sin, plus the same cosec square A I am going to write here, plus the cos square A here with plus 2 cos A into sec A is the reciprocal of cos A, so 1 by cos A you can write, plus sec square A. In the second step, I transferred only cosec A to 1 by sin A and sec A to 1 by cos A. The formula is cosec and sin are reciprocal to each other, and the same way sec and cos are reciprocal to each other. This identity I applied at the first step. Now you can see that this sin A cancel with this sin A and cos A cancel with this cos A. The remaining terms I am going to arrange here, which implies sin square A plus, now here remains a 2 only, plus cosec square A plus cos square A plus, here remains a 2 only, plus sec square A. Again you are known with sin square A plus cos square A. If you can combine sin square A plus cos square A, when combining you get the answer as 1. Sin square A plus cos square A is known to as 1. This identity I am going to apply here, which implies sin square A and cos square A I am going to write in one bracket. Sin square A plus cos square A in one bracket, plus now remains a 2 plus cosec square A plus again a 2, here a plus, again a 2 plus sec square A. This much remains, which implies sin square A plus cos square A can be replaced with a 1. So 1 plus this bracket is 1. 1 plus 2 plus cosec square A plus 2 plus sec square A. You know that 1 plus 2 is 3. 3 plus 2 is 5. I am going to arrange it as 5 plus, now adding the numbers, then 5 plus, the remaining is cosec square A plus sec square A. Look at the RHS whether you reach there. No. Again In the RHS, you have now cos square A plus chi square A in the LHS. The RHS is again a square relation with the concept of tan square and cot square A. You are not that sec square A and tan square A has a relation, square relation. Cosec square A and cot square A also has a square relation that you need to apply here. What is the square relation connecting sec and tan? Sec square A minus tan square A equal to 1. This is the square relation connecting sec and tan. And the same, what is the relation connecting cosec and cot? Cosec square A minus cot square A equal to 1. This is the square relation connecting cosec and cot. I am going to apply that also, which implies 5 plus cosec square A need to convert. Cosec square A can be written as 1 plus cot square A. 1 plus cot square A plus, this is cosec square A plus sec square A can be written as 1 plus tan square A. 1 plus tan square A. So, after reaching this step, you need to look at the RHS. You know that both of them are square relation. You know how to connect them. Again, arranging 5 plus 1, 6 plus 1, 7 plus. There remains a cot square A plus tan square A. Look at the RHS. 7 plus cot square A plus tan square A, which is the same as RHS. Therefore, LHS equal to RHS and hence verified. Another question. Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta equal to tan theta. Okay, let us take the LHS to prove the RHS. Your LHS equals sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta. Here I am going to do a simplification in which taking sin theta common from the numerator. Here remains a 1 minus 2. From the sin cube theta, if you take 1 sin theta outside, there remains a sin square theta. The whole divided by. In the denominator, we can take a cos theta outside. Now here remains 2 cos square theta. 2 cos square theta minus cos theta taken outside, so remains 1. Look at the RHS. The RHS is tan theta. Actually, you get the answer tan theta now itself if you think that this sin theta by cos theta equal to tan theta. But the problem is that if these two brackets get cancelled, you reach the answer as sin theta by cos theta, which is tan theta. How we can cancel these two brackets? Both of them need to convert either to sin square theta or to cos square theta. We can check which is equal to. This bracket sin theta by cos theta, I am going to take it as tan theta. Now, what is the square relation connecting sin and cos? Both are squares, so sin square theta plus cos square theta equals 1. I am going to apply the relation here. 1 minus 2 sin square theta therewith in the numerator by. I am going to arrange the denominator 2 cos square theta. What is cos square theta? Cos square theta is 1 minus sin square theta. Don't forget to put the bracket. 1 minus sin square theta. More than one term in one bracket. Now remains a minus 1. My aim is to cancel these two brackets so that we can arrive at the answer tan theta. For to cancel the brackets, I am going to convert both the sin and cos to the single unit. So here cos square I converted to sin square. Okay, we can simplify. Now tan theta remains outside. The numerator no change, 1 minus 2 sin square theta by. Denominator I am going to simplify. 2 into 1, 2. 2 into minus sin square theta minus 2 sin square theta. Now a minus 1 remains there. equals tan theta into, check whether you can cancel these two bracket sets, 1 minus 2 sine square theta by, what is 2 minus 1? Here remains a 2 and a 1. 2 minus 1 is 1. There remains minus 2 sine square theta. So my aim is to cancel these two brackets to get the answer tan theta. Converted both of them to sine square theta. Now 1 minus 2 sine square theta, the numerator cancel with 1 minus 2 sine square theta. So the answer is tan theta, which is your RHS.